Okay. Hi, everyone. We're so happy you've joined us here today. We'll start today's session with an introduction to relevant climate science, a live demo of the web portal, ClimateData.ca, before looking at projections for humidex and one of the tools available to explore heat waves. And finally, we'll wrap up with experiences communicating extreme heat risk to government and communities. We'll have plenty of time today for questions, which we welcome in the chat at any time, or by raising your hand and coming off mute during the question times. Climate change is going to impact different areas of Canada in different ways, so please let us know in this poll where you're located while I continue my presentation. So where does climate information play a role in public health? Knowing what your purpose is, let me see if I can, I don't know if you see that poll, I apologize. Knowing what your purpose is will help you when you need to make detailed and specific decisions about which data to choose. For broad commitments to climate action, high-level themes and trends for variables like average temperature can be where climate information comes in. For a specific impact or a project that is meant to deal with a changing climate, more precise and complex variables and data are needed for an intermediate level of detail. And for detailed technical needs for specific climate issues like extreme rainfall, technical risk assessments are necessary using in-depth detailed data. We are curious to see how people may already be using climate data. A poll will come up shortly that will allow you to let us know how you are using climate data, so please take the time to fill this in. Okay, so some people are starting to fill it in. Thank you everyone for participating in the poll. We really appreciate the responses, and please continue to answer the poll as I move along. We'll start now with a refresher on the differences between weather, climate, and natural variability. Weather is what happens fairly immediately, between days and months, like a heat wave, a thunderstorm, maybe a monsoon season. Moving to the other end of the spectrum, the climate is the long-term statistics of weather, so we're talking multiple decades to centuries. And the intermediate time frame, from months to decades, is where we see natural climate variability, which is caused by internal forcings in the climate system or forcings that are non-human related. For example, most of you have probably heard about El Niño events, which can last several years and which are caused by fluctuations in temperature between the ocean and atmosphere. Climate change spans decades and centuries and means long-term changes in climate. Because natural variability can cause short-term climate trends that may last from several months to several years and even a decade or two, we make sure to measure the climate and determine climate trends by looking at least 30 years of data, so that we aren't just looking at short-term trends caused by variability. Platforms like ClimateData.ca provide 30-year averages. Depending on what timescale you're planning for, you may need to consider different aspects of weather, natural climate variability, and climate change. Let's use this graph as an example. If we look at the change in temperature in Canada between 1948 and 2020, we can see variability in the ups and downs of each year in the blue line. If we looked at, say, the mid-90s to mid-2000s, we would be forgiven for thinking that the temperature trend was actually going down. If we only look at small chunks like this at a time, we might see increasing, decreasing, or static temperature trends due to natural variability. But if we look at the whole record, we see a clear upward trend in temperature. This is climate change. This is why it's so important to view a minimum of 30 years of data to understand the long-term climate trends. This is also our first data tip. You'll see climate change projections provided over 30-year time periods. So to consider climate change, we use climate projections, which we get from climate models. Climate models break the world into small cubes and then represent Earth's physical processes within these cubes with mathematical equations, such as the way clouds form or the way water moves across the land. And then these processes are crunched by supercomputers. And then researchers add greenhouse gas emissions to the models to simulate how the climate is projected to change into the future. An important note, remember natural variability. The climate system is chaotic, so every time you run one of these models, if you tweak its initial conditions, you'll actually end up with different details, but importantly, the overall statistics and trends would remain the same. That's by design. Climate models should and do capture the range of possible conditions. They're not meant to recreate the exact timing of past events, nor predict the exact timing of future events. There also isn't currently a perfect way to mathematically represent the climate system, so each modeling group will have their preferred way of doing that, but this can be used to our advantage. Different modeling groups will produce runs of their models using the same driving inputs for all of their outputs to all be considered together as part of what is called a multi-model ensemble. And then you can use basic statistical techniques on this ensemble, like taking the median or midpoint result of the models, which in this image here is represented by the black line. This black line indicates that half the models are showing lower results in this line and half are showing higher results. This is our second data tip. It's best practice to always use an ensemble of some kind, either an ensemble of multiple models or an ensemble of multiple runs from the same model in some cases. You'll be presented with ensemble results on websites like ClimateData.ca, so no need to worry there, but keep in mind that you should never consider the results from, say, a single run of a single model. This will not provide you with a reasonable estimation of the range of possibilities in the future. This graph is a good way to illustrate how we handle uncertainty with future data. Uncertainty occurs because the climate is inherently chaotic. As we can see by the past station data in black on the left side of the graph, individual years vary considerably, which is one reason why 30-year averages are preferred when comparing past and future climates. As we mentioned in the previous slide, when using modeled data, we want to use an ensemble or set of models. The gray shading shows the ensemble results for the historical period. So what else can we learn from this graph? The past climate, even the recent past like the 2000s, is not a good guide for future conditions. This means it's important to use the best available future climate data now. That brings us to another kind of uncertainty, which is human behavior, or how do we know what societal choices will be undertaken to deal with the climate crisis? The answer is we do not know, and that's why we use scenarios shown here with the different color lines and associated shading. The most recent scenarios are called shared socioeconomic pathways, or SSPs. These provide a range of plausible futures based on low, moderate, and high emissions, shown in blue, yellow, and red respectively. In all but the best case scenario, the blue one, climate conditions keep changing with time through the century. In general, it's good practice to examine a wider range of conditions rather than trying to pick a single scenario and a single number. And this is our next data tip. Rather than just choosing one scenario, consider what range of conditions you need to plan for. For example, are you concerned with extreme values? What is the lifespan of your project or policy? Are there ways to build in flexibility to accommodate a broader range of possibilities as things change in the future? There is a common misconception that future climate data has too much uncertainty and that historical climate data is more certain, so we should use that. But in climate science, when we say uncertainty, we're more often talking about that range of possible outcomes rather than a lack of confidence in the data or methods. This slide is meant to be comforting. There's no perfect answer as to exactly what will happen, but as long as you can use any future projections as opposed to historical climate data, you will be closer to the bullseye. Using past climate data is equivalent to not even hitting the target at all, since the climate has already changed and that target has already moved. Climate projections, even though they do contain uncertainty, capture the present and future reality better than historical data possibly could. So now we're going to switch gears and move into the live demo of how to find data on ClimateData.ca. The variables we'll look at today are hottest day and tropical nights. Before we start, it's helpful to know that there are several different data portals where you can access reliable climate data, including the one shown on this slide. Today, we'll be working with ClimateData.ca. ClimateData.ca is a climate data portal produced collaboratively by the country's leading climate organizations and supported in part by the Government of Canada. The goal of this portal is to support decision makers across a broad spectrum of sectors and locations by providing the most up-to-date climate data in easy-to-use formats and visualizations. And now we have another poll. We're going to do a quick poll to ask about your experience with climate data portals. It might take a minute to show up. Here we go. Okay, so please choose all that apply and feel free to add more information in the chat if you'd like. Okay, so I see some answers coming in. That's awesome. Thanks again to everyone for participating. Now I'm going to share this next slide. Okay, So ClimateData.ca has many variables and higher resolution data down to 6 by 10 kilometer grids, and it's customizable. It also provides various temperature and precipitation variables for the past climate and projected into the future. I don't know if it's showing blurry for you, but it's showing for me here. I apologize for that. There are also location-based summaries and sector modules with additional resources and information. The custom data lets you go through and pick data specific to your project and needs, and you can download charts and also data sets like in Excel. What I'm going to do today is show you how to customize data, and you are welcome to go to the website and follow along while I walk you through. So I'm just going to pull up the website now. Please let me know if you can see ClimateData.ca. Let me go to the main page. Can everybody see? Okay.
Yeah, looks good.
Okay, thank you. I can't see the chat. Okay, so here we're on the landing page of ClimateData.ca. There are two ways to get into the data. You can go into the location option in the top menu bar here, and that's where you can find that. If you type a location, you'll be provided with a summary and access to data and charts. Or you can go by the variable, and that's how we'll do it today. So the variable's right next to it. When you click on variable, you'll be brought to this page with quick links to popular data sets. You can choose one of these variables or click on the View All Variables button to see a complete list of variables available on ClimateData.ca. For today, we're going to click on Hottest Day, which is the first link under Temperature right here. So this blue banner gives you information about the variable you selected, as well as a technical description that tells you exactly what the variable is. From here, we'll go with the default settings for the high emission scenario and then click on Explore. Takes a little second to load. After you click Explore, you'll be brought to this map of Canada where data for the particular variable that you chose is displayed. One thing I'd like to point out here is the How to Use This Page pop-up box. This is a very useful tool that can help you to get oriented. If you're new to ClimateData.ca, have a look at this as it takes you around all the different menus that you see and gives you information about how to customize this map. So if we close this box, we can zoom into an area of interest using our mouse or the plus or minus buttons located on the left side of the screen. At the bottom here, you'll see is a time period slider that you can adjust. Here, I'll slide it back to the historical baseline period of 1971 to 2000. And then I'll slide it forward again to a future time period, in this case, the end of the century, which is 2071 to 2100. And so we're able to look at how the variable changes over time, in this case for a high emission scenario. This gives us a high level view. You can then zoom into a location, or you can type the name of the location in the search bar. So that's what I'll do up here. And I'm going to type search for Kamloops. If you hover over the grid box, you'll see that the projected values for the end of century high emission scenario pop up. Once you click on a grid cell, so let's click that, you'll see this figure representing the data for the variable you have chosen down here. You have to scroll down a bit. You might get a separate place name, however. It's all within the same grid box and with the same data, so that's okay. What you see here is a chart with the climate projections for hottest day out to the end of the century. The low, moderate, and high emission scenarios are shown by the blue, green, and red lines and associated shading. The blue shaded area, so you see hovered over here, is the time period of interest. And if you hover over a particular spot on the graph, a pop-up box will appear. And this box provides the median and the 10th and 90th percentiles, or the projected range, for this 30-year time period for all three emission scenarios. I'm just going to quickly close this graph. Another thing I wanted to point out here is that you can view the data not only by gridded data, but also by census subdivisions, health regions, and watersheds. So you just select the View by drop-down menu over here, and then you have these. You can also change the variable that you want to see on the page. So up here, we'll go to hottest day, and instead of that, I'm going to choose tropical nights, which you have to scroll down through the other variables to find. So here we go into other variables, and we have tropical nights. So these are two things that you could do. And I'm going to stop here with the live demo, but as you can see, there are many choices you can make. I also want to highlight that there is a lot of supporting information that you could find in the learning zone up here or in the sector modules. So I'm going to stop sharing my screen now. And so now we'll take a quick time for pause and for reflections and questions, and a reminder to put them in the chat or hold them until the end, the Q&A at the end of the session. And so now I'm going to pass this to my colleague Elaine, who will talk more through the heat data.
Thanks, Ellie. Suddenly realized that I couldn't unmute, but there we go. Okay, so thanks for giving us that quick introduction to ClimateData.ca. I'm going to now go into a little bit more detail about our new humidex dataset and also the analysis tool, which Ellie mentioned. And both of these you can use to explore extreme heat in more detail. Although our focus today is on extreme heat, we're also interested in hearing what other types of climate data you need in your work and which we could potentially provide. So we have a poll question, and we'd like to know what other kinds of health-related climate information and data you're interested in. And we've given you a few options, but if there are anything else that you're interested in, please put that in the chat. And I will carry on and start introducing the humidex projections that we've recently added to ClimateData.ca. So the humidex is actually a made in Canada index, and it's based on temperature and humidity, as you can see in this equation. When I get rid of the poll, there we go. And it can be a better indicator of summer comfort or summer discomfort than temperature or humidity alone. Environment and Climate Change Canada has published guidance related to the humidex, which gives an indication of how much discomfort is felt on average at different humidex values. And obviously, the higher the value, the more dangerous the hot and humid conditions are to health. But humidex can be experienced differently, particularly by people who are members of vulnerable populations, such as seniors and children. And in fact, there's one Canadian study which has found statistically significant increase in mortality in the elderly once the humidex hits 35. So the projections of daily maximum humidex that are available on ClimateData.ca have been developed by my colleagues in the Data and Products Office at CCCS, and they're now available for the most recent climate model ensemble, which is known as CMIP6. A lot of work has gone into the development of these projections, and you can read more about that process in this article. And from these daily maximum humidex values, we've derived 3 indices. So we have the number of days with maximum humidex greater than 30, greater than 35, and greater than 40. And it is these 3 indices that you can find on ClimateData.ca. So let's have a look at the projections for the number of days with maximum humidex greater than 30. This is the least extreme of the 3 humidex indices available, but this threshold does indicate when the average person is likely to feel some discomfort in hot and humid weather. On the left, we've got the 1971 to 2000 period, which is used as the baseline reference period on ClimateData.ca. And on the right, you can see the end of century values for the moderate emissions scenario on the bottom and the high emissions scenario at the top. In the 1971 to 2000 image, you can see that the largest number of days with maximum humidex greater than 30 occur in southern Ontario and the southern prairies. End of century values show clear increases in the number of days above this threshold in both the moderate and the high emissions scenarios, with the largest number of days exceeding this threshold again being in southern Ontario and the southern prairies. But there's also a clear expansion of the area experiencing days with maximum humidex greater than 30. So as you just saw, you can zoom in on the map to view the results for any location in more detail. And here you can see the projections for the number of days with maximum humidex greater than 35 for Nanaimo, BC at the top, and then Barrie, Ontario at the bottom. So 2 locations with very different experiences with extreme heat. So the median values of our ensemble are shown by the bold lines, and the range as defined by the 10th and 90th percentiles shown by the shaded area. So for our low emissions scenario in blue, our moderate emissions scenario in green, and our high emissions scenario in red. For days with maximum humidex greater than 35 in Nanaimo, there's very few occurrences during the historical period, which is shown in grey here. And it's a similar picture at the end of century for the low emissions scenario. We have less than 10 days for the moderate emissions scenario, and then about 40 days under the high emissions scenario. For Barrie, on the other hand, during the historical period, we have about 10 days with maximum humidex greater than 35. For the low emissions scenario at the end of century, it's about 20 days, 40 for the moderate emissions scenario, and 90 for the high emissions scenario. So the low scenario is projecting a doubling compared to historical conditions, the moderate scenario a quadrupling, and then about 9 times as many under the high emissions scenario. So that's a very brief introduction to the new humidex projections. Hopefully you'll have some time to go and have a look at them on ClimateData.ca and explore them in a bit more detail and explore the changes projected for your location. So I'm now going to move on to the Analyze tool. For many applications, the climate variables and indices that you find easily on ClimateData.ca will be sufficient to get you started. But if you want to use a different threshold value with a particular index, or you want to look at heat waves, this is when you would need to use ClimateData.ca's Analyze tool. This tool analyzes the climate model data for the ensemble you select, so CMIP5 or CMIP6. Those are the 2 main data sets that we have available for the locations that you're interested in, and it then returns a statistical summary of the projections based on the threshold values you supply. So basically, it provides all the information that you need to construct a time series chart similar to the ones you've seen in this presentation and that you'll see on ClimateData.ca. There are 5 main steps to the analysis process, and it's the 3rd step where you enter the threshold values for the variable you're interested in, so the Customize Variable step. There are a number of temperature and precipitation-based indices available, including 3 heat wave indices. The simplest of these is heat wave, and this is defined using only a maximum temperature threshold over a user-defined number of consecutive days. Then we have 2 similar indices, heat wave total duration and heat wave frequency. Both of these indices use a maximum and a minimum temperature threshold over a user-defined number of consecutive days. Heat wave total duration gives you the total number of days in heat wave events over the time frequency that you select, so by year, by season, or by month, whereas the heat wave frequency returns the actual number of heat wave events, and again, over the time period that you select, so year, months, or seasons. In the final step of the analysis process, you can specify the temporal frequency over which you want the analysis to be performed. And this is important if you want to explore how the occurrence and frequency of events changes within a year. And I'll show you just some examples in just a moment. So if you want to use the analysis tool, you're going to need some threshold values. You may already know relevant values for your location, but if you don't, then you can use something like the Meteorological Service of Canada's heat warning criteria to inform your heat wave threshold values. I'm going to show you some results for Barrie, Ontario and Nanaimo, BC. So I've highlighted the location and also the relevant criteria. So we have Barrie in the yellow area here and Nanaimo over in the blue area here. So for Barrie, the criteria for issuing a heat warning are when maximum temperature is forecast to be greater than or equal to 31 degrees Celsius, minimum temperature greater than or equal to 20 for at least 2 consecutive days. For Nanaimo, in the blue region, the criteria are maximum temperature greater than or equal to 29 and minimum temperature greater than or equal to 16, and again for 2 consecutive days. For Barry, you'll notice that there's also a maximum humidex threshold. So in this case, maximum humidex has to be greater than or equal to 40. The analysis page allows you to calculate the number of days with maximum humidex above a particular value. So you can explore thresholds other than the 30, 35, and 40, which are provided. But it doesn't yet allow you to use the maximum humidex value in the heatwave context, i.e. to consider a particular maximum humidex threshold over a particular number of consecutive days. To be able to do this on ClimateData.ca, it will take some work. So we're interested in finding out whether this would be useful to you. So we have another poll question. So if you were exploring future heat wave projections, would you be more likely to use temperature thresholds or a maximum humidex threshold? And this will determine how useful it would be to have that maximum humidex included in the heat wave indices of variables. So it's looking like it's almost half and half at the moment. So well, that's useful information for us anyway. So thank you for responding to that poll. Okay, I'll take that back to the team. So what can you do once you get your output from your data request, your analysis request? Well, it's relatively easy to construct charts. And data is returned, you can choose which data format you want your data returned in, but generally it will probably be comma separated value or CSV. And this is easily imported into software such as Excel. And within Excel, it's relatively easy to graph the median values for each of the emission scenarios. So here you can see the median values for the low, moderate, and high scenarios for Barrie, Ontario. So using those heat warning criteria for Barrie. And it's also relatively easy to plot there we go. The median value and the range for a single emissions scenario. And again, here you can see the results for Barrie, the median with the bold line and the shaded area representing the 10th and 90th percentiles. But in Excel, it's not very easy to put all three emission scenarios on one chart. It is possible, but it does require some careful chart formatting and manipulation. However, if you're familiar with a programming software, such as R or Python, then it's possible to plot all three emission scenarios relatively easily. And this is what I've done for Nanaimo, BC. So this chart has been constructed using R. I just want to highlight that something that you can't do with the data that's returned from the analysis page, and that's to calculate the 30-year averages. The analysis page is returning percentile values and not actual model values. So you can't average percentiles. It's not the correct thing to do. But hopefully in the future, we will be adding 30-year averages to the output from the analysis page. So the previous charts showed results at the annual timescale, but if you select to have the results returned at the monthly time frequency, then you can start to explore how the frequency and occurrence of heat waves changes over time. So these results are for Nanaimo in British Columbia, and therefore the CMIP6 high emissions scenario, which is known as SSP5 8.5. We've got the median values on the left, so P50, and we've got the 90th percentiles on the right, P90. And along the bottom of these charts, we've got the years, so from 1950 through to 2100. And on the vertical axis, we've got the month, so May through to October. And you can see two things from these charts. So first of all, you can see that the total number of heat wave days increases towards the end of the century. So you can see the intensity of the color increasing as we move towards the end of the century, indicating increases in the number of days. And secondly, you can see how the occurrence spreads into the shoulder months as we approach the end of the century, so indicating that the heat season is expanding. So in the median values, these are showing the midpoint of the climate model results, but to be best prepared for future conditions, in this case, it's important to also look at the upper end of the projection range, so the 90th percentile values. And so for Nanaimo, you can see that the heat wave days towards the end of the century start to occur as early as May and continue through to October. as well as obviously during the typical summer months of the year. So this has just been a very short introduction to ClimateData.ca, and we hope it's enough to get you started on your journey to go and explore future climate projections, particularly those related to extreme heat in your region. So if you have any questions on this part of the presentation, please put them in the chat or save them until the Q&A session at the end. And I just want to say that if you do have any questions sort of after this presentation or in general about climate data and how to use it, you're very welcome to contact our support desk at the Canadian Centre for Climate Services, and you can see the email and the telephone number here. So please feel free to reach out to the support desk if you have any queries. I'm now going to hand over to Craig Brown at Vancouver Coastal Health, who's going to talk about their experiences in communicating extreme heat.
Thank you very much, Elaine, and thanks everybody for being on the call today. And I've been tweaking my slides a little bit as the chat evolves here. It's always fun to see lots of activity there, lots of great questions, and some questions that I've had too. So thanks for that. And I'm going to try and keep this to 10 minutes. So apologies if I speak too quickly. I've tried to omit a couple of slides, and I'll try not to speak too fast. So I'm a senior scientist of climate change and health at Vancouver Coastal Health, and part of a big and wonderful and growing team of folks here that work on climate change and health on a daily basis. It's been pretty wonderful. It's sometimes difficult subject matter, but it's really nice to be doing something about it. So I'll start too by just saying that Vancouver Coastal Health operates on the traditional unceded territories of 14 First Nations here in British Columbia. And we're just getting better and better at building those relationships and centering their work and finding ways to support Indigenous-led efforts on climate resilience and beyond. And been a very great part of my job over the past few years to try and be involved in that work. For those of you outside of British Columbia, Vancouver Coastal Health is one of 5 regional health authorities, plus the First Nations Health Authority and BC Centre for Disease Control. We, like the other 4 regional health authorities, oversee primary care, community-based residential, home care, mental health and substance use services, and public health. And I'll be speaking today from the public health perspective primarily, where our primary concern is protecting health in communities as the climate changes. Some of the services that we offer, and this isn't meant to just be a list of of the things that we do, but it's really a way to start the conversation of how climate data, climate projections, just an awareness of the climate emergency kind of permeates all of our activities increasingly. And it's also important to note that even across our public health teams, pop health, health protection, et cetera, we're seeing this more and more in people's daily work, which is fantastic. Whereas 3 years ago, it used to be a smaller handful of us working on this. It's now much more of an all hands on deck situation, and that's very heartening. So there's some of the services that we do. I'm going to give you an example of a high-level risk assessment that we did and some of the climate data that we brought into it at the time, noting that this space is rapidly evolving. If you had done a climate change and health vulnerability assessment, in 2016, it would be vastly different from the one that myself and colleagues from Fraser Health did in 2019, 2020, 2021. And it would be different from the one you would conduct now because the data landscape has just changed so much. So essentially, this vulnerability assessment sought to understand what hazards VCH communities were exposed to, what was the extent of that exposure, what vulnerabilities existed, and what risks would be created as a result. And I'm going to focus on the data that we used. It was really, I think, a key message is that you still have to triangulate, even by bringing different variables together, but certainly by bringing different data sources together. And so some of those that I've listed, we were fortunate to have ClimateData.ca online at the time of doing the research for this report, which was wonderful. Again, if we were doing this 5 years ago, we wouldn't have had that. We would have used a Canadian Climate Atlas, and before that, we would have used all sorts of other sources that you don't even need to know about anymore. The CCCR report, the Bush and Lemon 2019 Canada's Changing Climate Report, is still, I think, a foundational resource for many of us. For sea level rise, for example, that was a great place to go for information for us. It's currently being updated. I think it'll be released in 2024, re-released or an updated version. So that's great. We relied too on gray and academic literature. So for example, for wind, for those of you that have tried to get wind projections for, say, impacts on facilities, or to try and tell a bit more of the story around electricity disruptions, it can be really challenging. There was a big piece put out. It's Canon is the author, and it's a federal entity that put it out. It still is fairly low confidence in the future projections, but at least it was something. And again, I'm sure that's changed since I've taken a look at it. It's rapidly evolving and refining itself. We did struggle sometimes with historical data. I still wish that was easier to just punch up what was the baseline average, say, from 71 to 2000, or in the last 30 years, or what are the history of extreme precipitation in this area. That's continuing to improve, but that was a challenge for us at the time. And then we would corroborate our various findings with existing projections reports. So those of you from the West Coast might remember the Pacific Climate Impacts Consortium, and some consultants put together various projections reports, for example, for Metro Vancouver. So we were able to kind of, again, triangulate there. Fast forward to now, our facilities management team have commissioned a piece of work that brings together all relevant climate variables across 45 different sites in Vancouver Coastal Health. And the hope is, I think, that this will be available to other health authorities too, for those of you on the line from BC for use. It's a really handy tool. I'll just skip to the next slide so you see it. I mean, it's basically a spreadsheet, but they've done as best they can to bring in all of the relevant variables. And so I pulled out this wildfire example to reflect a question in the chat earlier. Basically, the incidence for interface fire risk was pulled from a risk or a threat classification map that we've got in British Columbia. I don't believe it accounts for future risk, though. The future risk is still tricky. I think it's underpinned primarily by a couple of key papers that are listed, for wildfire occurrence and fire spread days. Still, the project here that I'm describing used those papers. And then wildfire smoke exposure actually uses some data that we pulled together with Metro Vancouver, who does air quality monitoring here in Metro Van, to look at historical exposure. So it's still not perfect. And perhaps Ellen and others can talk about if there's similar indices to the drought one that they mentioned in the chat. So I will move forward. One thing that's very hot off the press, I didn't get permission to share this yet, but Angela Yao from BC Centre for Disease Control and her team have pulled together a tool for health authorities where we just go to the drop down. We select our health authority. We decide what kind of region level we want. Now we're at a health service area level. We can look at specific communities, specific variables. So it's almost like an aggregator for the ClimateData.ca information. So always making this stuff more and more user friendly. I think we're seeing a lot of work by the Canadian Centre for Climate Services and others in this area, which is great. So when it comes to communicating these risks to people, I think, we do a lot. You could go to our website, so I don't have to go into too much detail here at vch.ca/climate change or /heat, and you'll find all the various resources that we produce and refine on an ongoing basis for communities. It's all underpinned by a sense that these risks are only going to intensify as the climate changes. And for me, I think, and for many of us in British Columbia and maybe across Canada, there's pre-heat dome and there's post-heat dome. Pre-heat dome, we were concerned about getting future projections and trying to tell persuasive stories, and that's no longer a concern. It evaporated really overnight, and now we're really just in trying to take impactful action. One thing that we're currently trying to do is gather more information about electricity outages. We're, I think, blessed in British Columbia, A, with clean electricity, but B, with a really leading utility in BC Hydro, who's very transparent about impacts in winter storms and stuff like that. But it can still be difficult to know who in our giant bureaucracy should talk to someone in their giant bureaucracy in this rapidly moving climate emergency space. But that's kind of the exciting work, is trying to, do those puzzles in real time. And again, communicating those risks is something that we think a lot about. There's quantitative approaches like our heat surveillance dashboard, which is a pilot monitoring program that is still undergoing evaluation, but that shows, as you can see, historical and current temperatures on the blue and yellow lines on our graph in the center of the screen, and stacked bar graphs underneath that show the emergency department visits and the kind of the reason for those visits. Very quickly, and finally, we can take that data, we can look at models that we've built and that others have built on community vulnerability to, for example, extreme heat on the left. This is an index, that we built with UBC to take various community factors and create an index that shows where is most likely to experience those health impacts arising from extreme heat. And we've been tinkering with validation, as shown on the right. We haven't done anything in depth, but again, this is all underpinned by good heat exposure data, whether that's current exposure data or future. For current, there's all sorts of neat methods going on. Union for BC Municipalities has funded a bunch of heat mapping work out here, and some consultants are doing really great stuff with satellite data and stuff. There's also been crowdsourced bicycle mounted thermometers driving around Vancouver on hot days to give them a relative sense of their temperature. So there's all sorts of cool ways to get that weather data and to augment it with climate data from CCCS and from other sources as well. I think, just in the interest of time, I'm going to skip my last slide and just say really happy for the opportunity to talk about this work. Available anytime to chat more, and over to Leah and Gregory for a bit of a Q&A. Thank you, everybody.